Friends, today I am going to teach you about inertial frames of reference and gallelian transformation.
So, our first topic is inertial reference frame. Think a person is sitting in a room. Do you think he is in a rest? Yes, with respect to the room or surroundings, he may be at rest. But what if he is traveling in a train and an observer is watching from outside? Surely the observer think like he is in motion.
From that experiment itself, we understand that motion is relative. So here is the importance of reference frame. So we will move on to study about reference frame.
So, think a person is sitting inside the train and two people are watching him from outside. Do they feel like he is in rest or motion? Their reference frame is the land or earth. So they will surely feel like the person inside the train is moving. Think a person is sitting inside the train and two people are watching from the inside of the train. What they feel like. For the two-person, the guy inside the train is not moving. He is at rest because their reference frame is inside of the train.
So we already discussed about the reference frame. This reference frame is an object or person or a location which is considered to be still, and we access the other object's motion relating to this reference frame. This is what reference frame is usually used for. Then we will move on to the inertial reference frame and non-inertial reference frame.
Inertial reference frame. An inertial reference frame is one in which object either remain at rest or move at constant velocity. Non-inertial reference frame. A non-inertial reference frame is one that accelerating or rotating relative to an inertial frame.
As you seen in that inertial reference frame definition, inertial reference frame should be at a constant velocity or should be at rest. It should always obey the Newton's first law. Unless an external force applied on it, it should maintain that constant velocity or rest form. We have understand about inertial reference frame. Now we have to talk about non-inertial reference frame. Non-inertial reference frame are frames that accelerate and rotate and affected by different external forces. It is different from non-inertial reference frame because non-inertial reference frame do not obey the Newton's first law.
Examples for non-inertial reference frames are accelerating vehicle and rotating carousel.
Now let us discuss about Galilean transformation and its applications.
Galilean transformation. Galilean transformation provides the mathematical relationship between the coordinate and time of an event in two inertial frame moving at a constant velocity. Now we can look into an example. A person is standing on the land and a bus is traveling through there. The land and the bus are two reference. So this man and the person in the bus is looking onto the sky and found a cloud. We taking this cloud as a coordinate. We are taking the man standing on the land as A and the man standing in the bus as B. A is in frame S1 and B is in frame S2. That means it's in bus. And we are taking the orange dot as the cloud. Now we are going to find the coordinate of the cloud from frame S and frame S2. So we are again marking that point as clouds. Then S, X, Y, Z, T is the coordinates of frame S and X2 coordinates are X dash, Y dash, Z dash and T dash. Here we also take time as one dimension. Now both A and B starts from the same point. After a time t, frame S2 travel d distance with a constant velocity. Here distance between A to B in x-axis is velocity into time. Now we are going to draw the diagram again and mark the distance between A to cloud and B to cloud and distance between A and B. The distance between A to cloud is marked as x, and the distance between B to cloud is marked as x dash, and distance between A to B is d is equal to vt.
So we are moving on to our final step. We are going to find the relation between the coordinates of frame S1 and frame S2.
Now let us find the relationship between the coordinates from the diagram. You can see the y coordinate is not moving. Therefore, y dash is equal to y. Same for z coordinate. Z coordinate is also not moving. Therefore, z dash is equal to z. Also for the time dimension, because time is same for both the frames. In 10 seconds, the frame move that much, and one frame continues in a point. Then it come x dimension. In the x dimension, the frame is moving. So we can see x is equal to x dash plus vt from the diagram, and x dash is equal to x minus vt. We can derive that.
We completed the Galilean transformation. But this Galilean transformation have some limitations because when it comes to the case of objects moving in a high speed or high velocity or close to the velocity of light, we can't describe it with this Galilean transformation. We need Lorentz transformation for that. Thank you.